Hey, Guide. I've always wondered, how does a bee sting? They seem so busy and friendly, buzzing around flowers, so why would one attack me?
That's a great question to start with. Bees aren't out to get us on purpose. They're just protecting what's important to them. Imagine if someone came too close to your home and started poking around. You'd want to scare them off, right? For bees, stinging is like their built-in alarm system. It happens mostly when they feel their hive is in danger, like if you accidentally swat at one or step on their nest. They're defending their family, the queen, and all those baby bees inside.
Oh, so it's not because they're mad at me personally? Like, they don't just sting for fun?
Exactly. Not for fun at all. Bees are super focused on making honey and helping flowers grow. That's their job. But if they sense a threat, like a big shadow or a sudden movement, they release a special smell that says danger to the other bees. The sting is a warning shot, kind of like yelling back off without words. It tells intruders to leave the hive alone. Most of the time, honeybees only sting when they're really scared, not because they're mean.
That makes sense. I saw a bee once near my picnic and it buzzed away fast. Was it just checking things out?
Yep, probably just scouting for food. Bees are like tiny explorers, tasting nectar from flowers to bring back to their hive. But if you wave your arms or try to shoo it roughly, that could feel like an attack to the bee. It's all about feeling safe. Think of it like a guard dog barking at strangers. It's not personal, just instinct. And not all bees sting the same way. Some, like bumblebees, are gentler and sting less often because their hives are smaller.
What if I'm allergic? Does that change why they sting?
The reason they sting doesn't change. It's still defense. But for some people, the sting causes a bigger reaction because their body overreacts to the venom. It's like how one kid might shrug off a scraped knee, but another cries a lot. Bees don't know that, though. They're just doing what nature wired them to do. In the wild, stinging helps the colony survive against predators, like bears or wasps, who might raid the hive.
Wow, so bees are like brave little soldiers for their home. I feel kind of bad now for being scared of them.
It's okay to be cautious. They can sting if provoked. But understanding this helps us respect them more. Most bees you see alone are just workers, foraging, not guards ready to fight. By staying calm and still, you give them a chance to fly away. It's all connected to how they live in such organized groups, each bee with a role.
Yeah, I get that now. They're not bullies, they're protectors. But how does the bee actually deliver the sting? Like, what's that part on its body do?
Great follow-up question. That part you're thinking of is the bee's stinger. It's like a tiny, hidden weapon at the end of their abdomen, the squishy back section of their body. Don't let its size fool you. It's super clever in design. Picture a fishing hook but way smaller and sharper. The stinger is basically two barbed shafts that slide against each other, like little jaws made of chitin, which is that tough, lightweight stuff insects use for their exoskeletons. It's not just a poke. It's built to grab and hold on.
A fishing hook? That sounds kind of scary for something so little. But it looks harmless when the bee's just flying around. How can it hurt if it's that tiny?
I get why it seems harmless. At first glance, it's only about 2 millimeters long, thinner than a needle you'd see in a doctor's office. But size isn't everything. Think of a thorn on a rose bush. That small point can still prick you bad. The barbs on the stinger point backward, away from the bee, so once it goes in, it doesn't slide out easily. It's connected straight to a venom sac, like a little poison pouch right behind it, full of that defensive juice we talked about earlier. And the whole thing is retractable. meaning the bee can pull it back inside when it's not in use, keeping it safe while they're buzzing from flower to flower.
So it's like a switchblade, hidden until needed?
Yeah, something like that. Nature's pocket knife. Only female bees and the queen have stingers, because worker bees are all girls doing the protecting. Males don't sting. They're just there to help with making more bees. The stinger evolved from an egg-laying tube in the queen, but in workers it turned into this defense tool. When the bee flexes certain muscles, those barbs pop out and the shafts start pumping, injecting venom drop by drop. It's all automatic, like how your knee jerks when the doctor taps it.
Whoa, so it's not just one stab, it's pumping stuff in? That explains why it swells up, I guess.
Exactly. You're connecting the dots already. The venom sac squeezes out about 0.1 microliters of venom per sting. That's a tiny amount, but potent enough to irritate your skin's nerves right away. Imagine a spicy pepper bite, but inside your body. It triggers pain signals to your brain super fast. And those barbs? They're what make it serious. They're like tiny Velcro hooks designed to snag on your skin's tough layers so the bee can deliver a full dose without pulling away too soon.
Velcro hooks. That's cool. And creepy. But if it's so hooked, what happens when the bee tries to fly off after?
That's where it gets interesting. The barbs catch hold, and if the bee keeps going, it can lead to some trouble for her. Does it always stick in there like that, or can it come loose?
I guess it doesn't always come loose easily, right? Like, those barbs sound pretty stuck once they're in.
You're spot on. Those barbs make it tricky for the bee to just pull out and fly away. But let's back up a bit to how the bee gets the stinger in there in the first place, because it's not like the bee just bumps into you and hopes for the best. Even though a bee is tiny and light, about the weight of a paperclip, it has some strong built-in muscles that do the heavy lifting. Picture the bee landing on your skin, maybe your arm during that picnic we talked about, and then it curls its abdomen forward like a scorpion does with its tail, but way gentler and quicker.
Curls its bottom? Doesn't that hurt the bee to bend like that?
Nope, it's totally natural for them. Their bodies are flexible, evolved that way over millions of years. Once the tip touches your skin, special muscles around the stinger contract super fast, pushing those two barbed shafts forward with a pumping motion. It's like a mini piston in a bike pump, back and forth, in and out, driving the stinger deeper without the bee having to use all its strength. Each pump is powered by oblique muscles in the abdomen, squeezing and releasing to jab it in about 1 millimeter at a time. And while that's happening, the venom starts flowing from the sac through a tiny canal in the stinger, right into the wound.
So it's not one quick poke. It's like the bee is drilling it in? That must take a second or two.
Exactly. It can take up to 10 pumps in just a few seconds, all automatic once the bee decides to sting. Think of it like how a woodpecker taps a tree to get at bugs. The bee's muscles create that rapid vibration to penetrate your skin's outer layer, the epidermis, without much resistance. Your skin is soft compared to the hive's waxy walls, so it slides in easier than you'd think. And the barbs help anchor it during those pumps, preventing it from slipping out too soon. The whole process is triggered by the bee's nervous system sensing danger, like your hand swatting close by. Zap, muscles fire, stinger deploys.
Whoa, so the bee's not weak at all for its size. It's got these hidden power muscles. But what if the skin's thicker, like on my hand? Does it still work?
Great point. On thicker skin, it might not go as deep, but the pumping action still gets enough venom in to do the job. Bees have stung everything from soft fruit to bear hides in the wild, so their stinger is efficient. Remember that time you tried squeezing toothpaste out of a tube that's almost empty? You have to pump the bottom harder to get the last bit. The bee's venom sac works similarly, with muscles squeezing it to force the liquid through, while the stinger's pumping. No waste, all defense. And once it's in, the venom delivery keeps going even if the bee starts to pull away, because the stinger has its own little pump mechanism.
That's smart engineering, like a toy syringe that squirts automatically. I didn't know bees were built like that inside.
Nature's full of surprises, isn't it? Yeah, it's all connected. The muscles not only insert the stinger, but also keep the venom flowing steadily, about 10 to 20 pumps per second at peak. That ensures the warning signal gets delivered fully. But you know, even with all that pumping, the real zinger comes from what's in the venom itself. What do you think makes that spot burn and itch so much right after?
I guess it's the poison stuff? Like, it must be super spicy or something to make it hurt that fast.
You're on the right track with spicy. That's a great way to think about it. The venom isn't like movie poison that melts things. It's a mix of chemicals made in that sac we talked about, designed to mess with your body just enough to say, get away. The main ingredient is something called melittin, which is a peptide, a fancy word for a short chain of proteins that breaks down cell walls in your skin. Imagine it like dropping dish soap into a glass of water with oil droplets. It bursts them open, causing all that instant burning, because it irritates the nerve endings right at the sting site.
So it pops the skin cells? That sounds gross, but why does it swell up like a balloon afterward?
Exactly. The swelling is your body's way of fighting back, like calling in the troops to surround the invader. Melittin triggers inflammation, which is when your immune system rushes blood and fluid to the area, making it puff up to dilute the venom and start healing. There's also histamine in there, a chemical that makes tiny blood vessels leaky, so more stuff floods in. Think of it as your skin yelling for help and getting a big red welcome party instead. And don't forget the acid part. Bee venom is mostly formic acid, which stings like vinegar on a cut, zapping those pain receptors super quick. That's why it hurts right away, before the swelling even kicks in. Your nerves light up like fireworks.
Fireworks in my skin? Ouch! Is that why some stings itch later, like mosquito bites?
Yep, spot on. The itching comes from that histamine too. It makes your nerves tingle and sends itch signals to your brain, like an annoying little alarm that won't shut off. For most kids, it's just red, swollen, and sore for a day or two. But the venom's job is done. You've learned to avoid bees, and the bees warned its hive. In nature, this venom evolved to deter bigger threats, like a skunk spray, but way smaller scale. It's not lethal usually, just a strong nope signal. Remember that time you got a splinter? The pain makes you pull it out fast. The sting does the same, but with chemicals instead of wood.
Yeah, like my body's built-in ow button. But does all that venom come out at once, or does it keep going?
It keeps pumping for a bit, even after the stinger's in, to make sure the full dose hits, up to 1/1,000,000th of a teaspoon. Tiny, but mighty. Other bits in the venom, like enzymes, help break down tissues a little, speeding up the irritation so the pain spreads. That's why you feel it throb. It's not just the poke, but this chemical cocktail working overtime. Scientists have studied it for medicine, actually. Small amounts can help with arthritis pain because it tricks your body into releasing natural healers. Cool, right? But for us, it's mostly about that immediate zap to keep predators away.
Whoa, bee juice is medicine? That's wild. I always thought it was just bad luck getting stung.
It's not luck. It's nature's clever trick. The venom hits nerves first for the pain, then causes swelling to isolate the spot and inflammation to heal it long term. Without that quick hurt, bees couldn't protect their home as well. But here's something interesting. Not every bee sting delivers the same amount. If the bee's young or stressed, it might be less potent. Still, that burn is universal. Evolution's way of saying, lesson learned. And speaking of the bee, after all that venom's out, does she just buzz off happy, or is there a cost to her?
A cost? Like, does it tire her out or something?
Well, it's more serious than just tiring her out. Stinging can actually cost the bee her life, and it's all because of those clever but tricky barbs we talked about. See, when the bee pumps the stinger in and starts to fly away, the backward-pointing hooks snag on your skin's tough fibers, like Velcro catching on fuzzy fabric. Your skin stretches and pulls back against the bee's force, and instead of the stinger coming loose cleanly, it rips right out of her body, taking part of her abdomen and that venom sac with it.
Rips out? That's awful! So the bee hurts itself to hurt me?
Yeah, it's a big sacrifice, but think of it like a soldier leaving a trap behind to stop an enemy. The bee's sting is her way of ensuring the threat gets the full message, even if she can't deliver it personally. Honeybees evolved this barbed design over time because their main enemies, like other insects or small animals, have thick hides or fur where a smooth stinger might just slip out without much venom getting in. By getting stuck, the stinger keeps pumping venom automatically for a minute or so after she's gone, thanks to some leftover muscle twitches in the detached part. It's like the stinger has a mind of its own, continuing the attack without her.
Whoa, so it keeps stinging even without the bee? That's intense. But why would nature make bees do that if it kills them? They seem so tough, buzzing all day.
Great question. Bees are tough in their own way, carrying pollen loads heavier than themselves. But sacrificing one worker isn't a big deal to the hive. A healthy colony has tens of thousands of bees, so losing one guard bee saves the whole family from bigger dangers, like a raccoon raiding the honey. It's selfless instinct, wired into their brains. The bee doesn't choose it thinking, oh no, it's just reflex. Without this, predators might keep coming back, but a stuck stinger with ongoing venom, that's a serious stay away sign that alerts the whole hive through that danger smell we mentioned earlier. Scientists call it altruistic behavior, helping the group at personal cost.
Altruistic? Like sharing your last cookie with a friend. But for bees, it's life or death. Does it always kill her, though? What if the barbs don't catch super well?
Not always, actually. That's an important part. If the bee stings something soft or smooth, like thin fabric or fruit skin, the stinger might pull out without tearing, and she flies off fine, ready to work again. But on human skin or animal hide, those barbs almost always hook in deep because our tissues are elastic and grabby. When it does tear out, the bee's abdomen gets this huge gash. Her insides spill digestive juices and muscles, and she can't fly or eat properly. She usually dies within minutes from the injury, all shriveled up. It's why you should scrape out a stinger gently with a credit card edge if you get stung, not squeeze it, or you'll push more venom in.
Yikes! I never knew it was that final for the bee. Kinda makes me respect them more, like they're real heroes.
Exactly. They're not villains in a buzzing horror story. They're part of an amazing system that keeps ecosystems buzzing too, pollinating flowers for our food. Most stings you get are from forager bees far from the hive, and understanding this helps us coexist better. Wear light colors, avoid strong smells, and let them be. No need to fear every buzz. It's all about that balance in nature. You've got the whole picture now. Bees sting to protect, deliver it smartly, And yeah, sometimes pay the ultimate price. Pretty cool how it all works together, right?
Totally cool. Thanks, Guide. I won't swat at bees anymore. Now I see them as busy protectors, not just stingers.